Good morning to all. This is Priyanka, and my topic is Bipolar Junction Transistor CB. Subject name Basics of Electronics and Electrical Engineering. Now let us discuss about bipolar junction transistor. It is also known as BJT. First of all, the introduction for this topic is the basic of electronic system nowadays is semiconductor device. The famous and commonly used of this device is BJTs. It is also known as bipolar junction transistors. It can be used as amplifier and logic switches. BJT consists of three terminals: collector, base, emitter. Two types of BJT are PNP and NPN. Transistor is a single crystal in which there are two PN junction diodes. Now let us discuss about transistor construction. Three-layer semiconductor device constructing two N and one P type layers of material NPN transistor. 2p and 1n type layers of material is known as PNP transistor. The term bipolar reflects the fact that holes and electrons participate in the injection process into the oppositely polarized material. A single PN junction has two different types of bias: forward bias and reverse bias. Thus, a 2PN junction device has four types of bias. Position of the terminals and symbol of BJT. Base is located at the middle and more thin from the level of collector and emitter. The emitter and collector terminals are made up of the same type of semiconductor material, while the base of the other type of material. See here figure A, position of terminals, and figure B, type of BJT. Common base configuration. Common base terminology is derived from the fact that the base is common to both input and output of the configuration. Base is usually the terminal closest to or at ground potential. All current directions will refer to conventional hole flow, and the arrows in all electronic symbols have a direction defined by this convention. Note that the applied biasing or voltage sources are such as to establish current in the direction indicated for each branch. And these are the figures of PNP and NPN transistors. To describe the behavior of common base amplifiers requires two sets of characteristics: input or driving point characteristics and output or collector characteristics. The output characteristics has three basic regions. Active region is defined by the biasing arrangements. Cutoff region is defined as region where the collector current is 0 ampere. Saturation region. It is the region of the characteristics to the left of VCB is equals to 0 volts. Here these are the input and output of the transistors graphs. Here there are three types of regions: active region, saturation region, cutoff region. Now let us discuss about active region. IE increased and IC also increased. BE junction forward bias and CB junction reverse bias. Refer to the graph IC curve IE. IC not depends upon VCB. Suitable region for the transistor working as amplifier. Now let us discuss about saturation region. BE and CB junction is forward bias. Small changes in VCB will cause big difference to IC. The allocation for this region is to the left of VCB is equals to 0 volts. Now let us discuss about cutoff region. Region below the line of IE is equals to 0 ampere. BE and CB is in reverse bias. No current flow at collector, only leakage current. The current curves output characteristics clearly indicate that a first approximation to the relationship between IE and IC in the active region is given by IC curve IE. Once a transistor is in the on state, the base emitter voltage will be assumed to be VBE is equals to 0.7 volts. In the DC mode, the level of IC and IE is due to the majority carriers are related by a quantity called alpha. Alpha is equals to IC by IE. IC equals to alpha IE plus ICB0. It can then be summarized to IC is equals to alpha IE. Ignore CBO due to small value. For AC situations where the point of operation moves on the characteristics curve, and AC alpha is defined as alpha is equals to delta IC by delta IE. Alpha, a common base current gain factor that shows the efficiency by calculating the current percentage from current flow from emitter to collector. The value of alpha is typical from 0.9 to 0.998. Thank you.